Okay, we are in text section 5.1. We're doing inference. This is chapter 16 in the JV Stats book. Okay, and this is going to be great. I really like confidence intervals. I find them very, very interesting. It's not particularly hard. However, at the beginning of the process, it'll be a little bit tedious. Okay. So we are, let's see here. We are right here in the process. We're doing proportions first. Let's go over this is the formula for a confidence interval. So you want to know what percentage of people will vote for candidate X, or how effective is this particular vaccine? What percentage does it affect? The first thing you get is an estimate. The estimate is called p-hat. And that estimate is just your study itself. So if we studied 100 people and 80 of them received benefits from the vaccine, we would say the vaccine is 80% effective. We might write it as 80% effective, or we might write 0.80. Either way is fine. And we'll kind of do both ways here. I think you guys understand percentages. Plus or minus is what indicates that we're going to be doing the margin of error afterward. And the margin of error, okay, is simply gives you some room for a mistake. So if 80 out of 100 are good with the vaccine, that doesn't mean by any stretch of the imagination that exactly 80% of the people are good to go. It might be 75 to 85%, somewhere in there. We're not sure. Okay. This right here is how you develop the margin of error. Okay. Z star is called the critical value. It's basically a Z-score. Okay. And so, for example, if you want to be 95% confident, 95% confident is approximately 2 standard deviations away from the mean. So you'd have a 2 there. You'd be a 2 there. If you want to be 68% confident, that's a weird number. From the empirical rule, that'd be about 1 standard deviation away from the mean. Okay. And then Q, of course, is the complement. Q is 1 minus P. It's the complement of P. And then N is the sample size. Okay. So this is pretty simple. Okay. Let's check it out here. So let's go to the next thing we're going to do. Okay. So let me slide this down a little bit. Slide this over. There we go. Okay. Find the expected proportion and the standard deviation of the samples. No problem. This is just a simple activity to get you going on this. Okay. So if you do some sample of size 59 and 18% come out in the sample, your expected proportion is 18%, or you might write 0.18, depending how you want to do it. Then the standard deviation of this is the square roots of 18%, the complement of 18%, divided by the sample size. And that comes out, 5.002, or you might write it 0.005, 0.005, depending on if you want it in decimals or in actual percentages. Either way is fine. Okay, so this is pretty simple. 26% of 3,125, if they sampled, 3,125 people and asked them, how many of you prefer strawberry over chocolate or something? And it came out 26%. Then we're thinking about 0.26 of the people around there. Now, this standard deviation, if we did the same study over and over, it would change. This is it again. 26 times 74 divided by 3125, and it comes out 0.785. That's in percentages. If you wanted it in decimals, it'd be 0.0785. So this standard deviation is less than 1%. If you notice, when you crank up the sample size, the standard deviation drops massively, okay? Now this last one, small sample size 83. 29 out of 83 is 34%, about 35%. You might put 0.35. you can see this drawn here. You might put something like 0.35, 0.65 over 83. And that will come out about 0.05233. It's about 5% is the standard deviation. Okay. So we're just doing some simple practice stuff, not hard, just walking it through. What's funny is you can teach this whole thing with the big picture and just do it. But you know me, I'm always trying to break it down into all these little teeny parts so you get it. You can definitely just kind of skip to the punchline on this. It's not very hard. Okay, MOE is called margin of error. Okay, the margin of error is the part after the plus or minus. Okay, the first question I ask of you is, how do you find the confidence level? What's that? If you want to be 90% confident, what's that critical value? If you want to be 99% confident, what's that critical value? If you want to be 80% confident, what's that particular critical value? And I need to stop the video just for a sec so I can get the formula sheet out, okay? Hold on. Okay, so let me erase this real quick. So if we want to be, let's see, the question was, if we want to be 90% confident, there's a table in the book, and it's also, AP gives them to everybody. It's the same one every year. 90% confident, there it is. That critical value is 1.645. And what that means is, in a normal curve, 90% of the values are going to be within 1.645 standard deviations from the mean, which is the middle. That's how you can get a 90% confidence interval. Okay, so there's 90. Here is 99. I think it was 99, 2.576. And the other one they wanted was 80. Very easy to find. Now, what this is right here, this is for the means. If you do not a proportion test, but a mean test or a mean experiment or a mean confidence interval, the means are going to be done using a table because we're going to use degrees of freedom, which I'll explain later. Okay, so that's how you get the answers to those. Okay, you got to find that formula sheet. It's usually called table B in front of a book. Okay, all right. So we got those. Now we're going to go backwards. Okay, now we're going to go backwards. The question is, the question is, find the confidence level given the critical value. All right, so we got 2.326, no problem. 2.326, look down here, 2.326, that is 98% confident. Okay, that's 98% confident. All right. The next one is, let's see here, 1.96. That is the most common one. That's 95% confident. I'll show you that one. And then the last one is 1.645. Let's slide over here and look up 1.645. We can do these both at once, actually. There's 95% and there's 90. 1.645. Those two are the most common. 95 is kind of the gold standard. Okay, so there's that. That's pretty easy. I'm walking you through how to find some things here. Now, the next one is find the confidence level given the margin of error. Okay, I'm sorry, we did that already. Okay, here we go. Find the margin of error. I'm on right here. Sorry about that. Lost track of my spot here. Find the margin of error given the confidence level, estimate, and sample size. Okay, no problem. Okay. The margin of error, the answer you can see is about 18%. Okay. How did we get this margin of error? 95%, if you remember, is 1.96. Okay. And we're going to multiply that by 64% times 36% divided by 28. And that will come out that. Now, if you do it in a decimal, it's going to be 0.17779 or about or about 0.18. Some books use proportions, some use whole numbers. But a margin of error of 17% is shocking. Think about it. If you had some estimate that's 64%, then you're saying you're 95% confident is within 64% plus or minus 18%. I mean, that's a ridiculous interval, which is almost useless. And the reason it's relatively useless is because your sample size is so low. Typically, people like 3% margin of error, typically, and you need samples in about 1,500 to get that, just so you know. You need a lot of samples to get that. Okay. Next one, margin of error here is about 6%. How did they get that? 80% confident is 1.282. And then we got to get this percentage 38 out of 103, which I don't know off the top of my head. So I'll get my calculator out. So 38 out of 103, 38 divided by 103 is, I'll go with 37%. Okay. It's going to be this times 37 times 63 over 103. Okay. Now you could do 0.37 and 0.63, and that'll give you 0.06091. Either way is fine, just so you know. Okay. And the last one, here we go. 47 out of 65, very small sample size, massive margin of error, 12%. Okay, so let's go over this one. 98%, clear this real quick. So let's walk through this. 98%. All right, so 98% is 2.326. You can see that on the chart, 2.326. All right, so I'm going to go 2.326 times, and then I need what 47 out of 65 is. So I'll get a calculator on the side here. 47 divided by 65. That's about 72%. So 72, 28, and then 65. And again, you'll get this answer 12.91, about 13%. Or you could write it as a proportion, 0.13. Okay. All right, pretty cool. Now let's go backwards here. Okay, let's go backwards. And we're going to find the confidence level given the margin of error. Okay, so they're going to give us the margin of error, and let's find the confidence level. All right, no problem. Okay, so the we don't know, this is the answer, of course. So margin of error is this. So I'm going to go Z star, so I don't know what that is, times, they give you P hat, 83% times 17% over 123 equals 5.572. Now, all you have to do is your algebra here. So all you got to do is your algebra. So what you're going to do is go ahead and figure out what this is, okay? And then, in fact, I'll go ahead and do that for you on my calculator. Again, I'm doing it on the side here, so I got a handheld calculator right here. So I'm going to go 83 times 17 divided by 123. And I'm going to square root that second answer. And I get something like this, Z star times 3.38696. It keeps going, equals 5.572. Now I'm going to leave that in my calculator. Okay, I'm going to leave this number in my calculator. And what I'm going to do is I'm just going to divide 5.572 divided by second answer. And I get, so Z star equals 1.645. And I look on the chart and that's a 90% interval. Okay. Not too bad. I probably won't do the other ones because you'll get the idea based on this one. Okay. So the second one, we've got a 99% answer. We already know the answer. Let's check it out. So we've got the margin of error is 12.664, and that equals Z star, which I don't know. And I got to figure out the percentage real quick. So on my handheld calculator, I'm going to go 27 divided by 88, and that's about 31%. About 31%. So I'm going to go 3169 over 88. Okay. Multiply that through, and Z star is going to come out, I believe, 2.576. If I look on the chart, that's 99%. And the last one, the margin of error is 10.272, and it's 53 out of 74. So I need 53 divided by 74. That's about 72%. A little bit of rounding error, but 72%. So I got 72.28 over 74. And we got Z star here. Okay. That equals that. So then we got Z star equals, it'll come out about 1.96. I have some rounding issues there, and that's about 95%. Okay. So that's not too hard to do, I don't think, anyways. All right. Next one. Determine if a normal model is appropriate, then construct the model based on the empirical rule. All right. So just so you guys know, whenever you're doing an inference procedure, and this is, we're inferring, which is making a judgment, that we can figure out where the true proportion is. You got to meet some requirements. You just can't do any old study. It's got to be a legitimate study. So there are 4 things that make a legitimate study. And I made an acronym. Many stats teachers use this acronym, okay, to help you remember it. It's called SPIN, okay? So S is you need a representative sample. In other words, you have to have good data. You know, when they ask voters what they think about the presidential election, you got to make sure you get voters. And then you got to make sure different people are represented from different points of view so it's accurate. In fact, recently I have a really good article on this, which I'll read in my classes eventually. It's about how 95% confidence intervals in polling, and you can see the article, I'll hold up the screen here, 95% confidence intervals in polling over the last 15 years have only been about 60% accurate, when in fact 95% confidence intervals should be 95% accurate. But they've been only 60% accurate. And what they're getting at is what they're saying is they're not getting a representative sample. Somehow people are not telling them the truth, or they're not just finding the right people in the right proportions. They're having issues, okay? You don't want to oversample, believe it or not. You don't want to sample more than 10% of the population. This is called the 10% rule. It's also written as the population needs to be 10 times the sample size. Each event needs to be independent, and then the sample size needs to be sufficiently large. NP has to be greater than 10, and NQ has to be greater than or equal to 10, Q being 1 minus P. Okay? There you go on that. So we're going to go ahead and show you now what the next steps are on this. Okay? You're going to like this. So let's see. Pen trouble today. Okay. Now, the definition of a confidence interval is right here. I kind of wrote it out in a little sentence frame. If we repeat this process many times, because you think about it, when they do an election, they're constantly repeating the process of asking people, then 68% of the time, we would expect it to be within 1 standard deviation right here, right? So that's the 68% of the time, right? Okay, 95% of the time will be within 2 standard deviations, and 99.7% of the time will be within 3 standard deviations. Just so you know, that's a little review of what we're trying to do. Okay. all that is a little bit, we're starting to get away from just literally making the interval, which we will. It's actually really easy, but I'm trying to show you all the pieces here. Okay, let's try 3A, B, and C. Okay, I just gave you sentence frames. All I'm doing. It's a little smaller. Good, there we go. Okay, determine if a normal model is appropriate. All right, so let's just check this out. If we can do this. McNopoly restaurant offers prize tickets for Jolly Meals, claiming 35% of the tickets are winners. You buy 30 meals. All right, this is the SPIN acronym. Okay, the first thing, we have to assume we have a representative sample of prize tickets. Step 2, the population of prize tickets needs to be at least 10 times the sample size. So clearly, I'm sure there's more than 300 tickets. Each prize ticket is independent. Now, do we have enough samples? I think we do. 35%, 0.35, times 30 is bigger than 10. And then 35% or 65%, that's 1 minus B, times 30, that's also bigger than 10. We are good to go on this, okay? We have a situation where I think for sure we'll be able to actually do an interval. We've met the requirements, okay? All right. Okay, next one, okay? Next one, there, okay. Next one. A poll conducted on 538 voters found that 317 of them preferred a Republican candidate. Fine. So what's P hat? P hat ends up being 0.589. Where do we get that? That is 317 divided by 538. Okay. Okay. The first one, assume we have a representative sample of voters. That's the S in SPIN. Okay. Assume the population is 10 times bigger than the sample size. I'm sure there's more than 5,380 voters. I mean, should we have 100 million people vote or 200 million or whatever it is? Okay. Voter preference is independence. And yeah, the sample size is large enough. I don't know if you can see that down there. Let me slide this up real quick. Okay. Yeah, it's large enough. So you can see it down there. We got N times P, that's bigger than 10 for sure. And then 1 minus P times N is also bigger than 10, no problem, okay? The last one that we're checking. So all of these are good to go. So this is the process when you're making a confidence interval. The first thing you got to do is say, do I have a legitimate study? Here's why I do, or don't. Okay. Adult women are being asked if they agree with the statement, being a stay-at-home mom is a job. Let me tell you something, it's a job. 29 of these women agree with the statement. So P hat is 0.784, okay? First thing, assume we have a representative sample of adult women, fine. Assume the population size of stay-at-home moms is at least 370, no problem. Each opinion independent. Let's check the last one though. The sample size large enough? I don't think it is, okay? N times P is big enough, but N times 1 minus P is not. It's a little shy, a little bit shy stuff, okay? So this last study right here, you would need more samples before you can actually conduct it and draw a confidence interval that has any validity. Okay, all right, fine. Now, next one we're going to do is we're going to calculate the sample size requirements. This happens all the time. How many samples do we need in order to conduct our study? Okay, so let me pause the video just for a second here. Okay, what we have here to find how many samples you need, this is pretty tricky. So you got 68% is the estimate for this situation, 95% confident, and they want the margin of error between plus or minus 5%. I wrote it up, but let me write it like this. So we got 5% equals 1.96 times 68%, 32% over n. Now you got to use your algebra. Some of you will be great at this, some of you won't. The first thing I'm going to do is I'm going to divide 5 by 1.96, and then I'm going to square both sides to get rid of the square roots. So let me slide over to the calculator at this point so we can figure this out, okay? All right. Okay. So hopefully you can kind of see it up there. I'll write it again. We got 5, oops, we got 5 equals 1.96 times 68 times 32 over n, okay? So we're good to go there. So let's give this a shot here, all right? All right, here we go. So I'm gonna go 5 divided by 1.96. Okay, you get 2.55. I'm going to square both. I'm going to square that. Okay, square it. Okay, so far, now if I'm writing this down, you can see my work as well. If I'm writing this down. What I have right now is I got 6.5077 equals 68 times 32 over n. That's what I have. I'm going to multiply in my head both sides by n, like this, correct? So now the n goes on the other side. So the final step is to go 68 times 32 divided by second answer, which is 6.5077. All right, so here we go. 68 times 32 divided by second answer, which is down there, right? And I get an answer of about 334, 335. So there's my answer to that. Okay. All right. So let's do the other ones just so you really see it well. Okay. All right. So let me go back to, let me lower this. Bring this up. Okay. Let's do the next one. 4B. Okay. We got on this problem, we got 68%, 95% confidence again, and they want it within 2 percentage points. So it's the exact same prompt, except it's 2%. So if you want it within 2%, you're going to need a lot more samples to get it narrower, a lot more. You can see the answer kind of prescriptive here. Okay. Let's go ahead and do this one, all right? So bring back up the calculator. Bring your calculator up. All right, so we got, I'll put the problem down here. 2%, within 2%, 1.96, and it's 6832 over n, okay? First step is, like I said before, we're gonna divide 2 divided by 1.96. 2 divided by 1.96. Okay, you can see the answer is 1.02. I'm going to divide that. I'm going to square that to get rid of the square root next. Okay, so there we go. So there is that answer. So where I'm at right now, or to draw this, is I got 1.04123, etc. equals 68 times 32 over n. I'm going to multiply n in my mind to both sides. So n's now on this side, okay? And now all I got to do is I got to multiply 68 times 32 and divide it by second answer. And there you go, about 2089. Okay, 2090 if you round up. Okay, So that's how you do that problem. The other two, I don't think I'll need to do. I mean, I'll show you the answers and everything, but I think we're okay after that. Okay. All right. So the other two answers, okay, for C and D. You can see the setup. You can pause the video here. You can kind of check it out and see if you can get the same answer using the techniques that I used. Okay. Finally, item 5, we're going to create a confidence interval. Whew. So all of this stuff, it sort of comes down to this moment. Let's create a confidence interval. Now, some teachers may just start here. This wouldn't be a bad starting point, and then you go back later and you check everything else out. But I chose this at the very end. But this is the punchline. Procedure. Find the estimate, P hat, find the estimate. Find the margin of error, and then make the confidence interval. No problem. Here we go. 18 of the 52 people polled said they believe in ghosts. Create a 90% confidence interval for the percentage of people who believe in ghosts. Now, I'm going to give you a beautiful shortcut. Beautiful shortcut. Now, if you want to do it by hand, you can. But again, this is the punchline. So P hat, 34%. You see that? 34%. Okay. The margin of error, so is going to be 1.645. Where did I get that? That's 90% confident. Looking on that chart, changing it to the critical value. And this is the square root here. The percentage, 1 minus a percentage over that. Okay. And if you do the math on it, you end up getting this answer somewhere between 24% rounding and 45% of people believe in ghosts. That's a pretty big area, 24 to 45%. The reason it's so large is because our sample size is very small, 52 people. Now, let me show you an incredible way to do this quickly on your calculator. Okay. Your job would be to set it up. So you could do a couple of ways. You could point 0.34615 times, 0.34. I'm rounding. 0.34 was that 66 over n, which is 52. Okay. Oh, sorry. Plus or minus. I missed this whole thing out. Let's try this again. We could do 0.33. I'm going to go 0.35. 0.35 plus or minus 1.645 times 0.35. 0.65 over n, which is 52. You got to set that up on your sheet. Now, the calculator will do this for you. You're going to love this. You're going to love this. Okay. So I remember our numbers here. 18 of 52 at 90%. All right. So let's go to the calculator. Okay. So we're going to go let's go stat and over to tests. Okay. My mug here. Stat tests. All right. Now, when you do this, you're going to go down to one prop Z interval. This is a one proportion interval. Where it is, it's coming, it's coming. One prop Z interval. On my calculator, it's item A. One prop Z int. Check this out. That was stat test. Hit enter. And it was 18 out of 52. And you want 95% confident. It was 90. No, it was 90. It was 90 that we wanted, 0.90. With that, hit calculate. There it is. Isn't that great that there's a button on the calculator? So all that I taught you You can do it on a button on the calculator, but you want to be able to understand everything. So that's good. Okay. So let's do the next one. Okay. So the next one, okay, myself again. 42 of 97 people surveyed say they will not vote in an upcoming election. Create a 95% confidence interval. 95. That's 1.96. So here we go. Okay. So how you would do it is you would go 0.43 plus or minus 1.96 times 0.43 times 0.57 over 97. Okay, that sound good? And then you're going to end up with this answer right here. Okay, let's go to the calculator and let's just check this out and see how we can do it. So it's 42 of 97 at 95% confidence. Okay, let's try this again. Stat. And go to tests. Go to the data bunch. One prop Z test, or Z interval, one prop Z interval. Great. And I forgot the numbers already. It was 42 of 97 and 95%. Okay. So I'm going to go 42 of 97. Again. Of 97 at 95% confidence, 0.95. Calculate. And this gives the answer in a decimal. There we go. Between 33 and 53% on that one. Between 33 and 53. Usually just go to two spots. 0.33 to 0.53. That's good. Okay. Most percentages are done to the 100th power. Okay, pretty cool. All right. Okay, next problem. So let's clear this. Next problem. Let's C and D here. All right. Food and Safety Committee randomly inspected 58 oranges and found 7 of them were contaminated with fruit fly disease. 99% confidence. No problem. The first thing we got to do is write it out. Okay. This is about 12%. So 7 of 58 is about 12%. So it's 0.12 plus or minus. 99% on the chart is 2.576. So you're going to write that down. And then you're going to write in 0.12, 0.88 over 58. And again, you could write the number 12 here and then write 12, 88, and 58 there, and you'll get the number in percentages, whole numbers. Just depends how you want to do it. Fine. Okay. So I'm going to memorize 7 of 58 at 99% confident. All right. So go to this. Okay. I'm going to go stat tests. And I'm going to go backwards the other way. I'm going to go to right in the middle of it. One prop Z interval right there. It was 7 of 58 at 99% confident. Okay. And it looks like it's between 1 and 23%. Wow. Between 1 and 23%. That is a crazy, that's really a wide interval. Between 1% and 23%. I mean, what's the story with that? Why is it so wide? Well, the reason it's so wide, and I have like 1% here, is because you have a really small sample size of 58, and that's going to yield a really big interval because you really don't know where things stand on small sample sizes. When you get in the thousands, you know it's going to be around a 3% margin of error, which is people like. Okay. Last one. Okay. This one will be a little better. Okay. Bag of N and Ns, okay? 103 pieces of candy, 21 which contain almonds, the rest peanuts. Create an 80% confidence interval for the percentage of M&M candies that contain almonds. All right. So 21 out of 83 is about 20%. So it's going to be 0.20 plus or minus. And 80% is 1.282 off the chart. And we're multiply it by P, or P hat, 1 minus P hat over N103. So I've set it up. And I'm just going to use my calculator. The answer is going to be between 15 and 25% are the answer. Let's go ahead and do it, okay? So let's go back to the calculator. Okay. So I'm going to go stat over to tests. And I'm going to do one prop Z test or interval, one prop Z interval. Got the numbers already. 21 out of 103, I think. 21 out of 103 at 80%, right? So here's 21. Here is 103. And it was 80%, 0.8. Okay. I think it was 0.8. Let's check one more time. Yeah, 80% interval, 0.8. Okay. Back and forth, and this is pretty hard for me. All right, 0.8. Calculate. Boom. Between 15% and 25% is where we think the truth is. Okay. All right. So that is the end of that particular lesson. That is just real quick here. All right, that was chapter 16 in the book, section 5.1. Thank you so much, Stat Nation, for listening. Be back at you next time.